Hey y'all, my name is Mr. Canada and welcome to my math domain. In this video, we're going to be talking about solving linear equations using simplification techniques. Our whole goal is that we want to go ahead and know what are the ways that we can simplify an equation and actually seeing how those simplification techniques come into play. So why do we even need to simplify a linear equation to begin with? Well, basically we want to simplify it because there's going to be problems where we're going to end up having more than one variable in our equation. And what we really want to try to do is we want to try to get it down to an equation where we can easily solve it in two simple steps, both using inverse operations. So these two-step equations are the most basic type of linear equation that's provided to us. So if we can get it looking like those types of problems, it's going to be a cakewalk later on. So what are the ways that we can simplify a linear equation? Well, there's actually three techniques that are in our tool bag. The first technique is multiplying using the distributive property. Basically, what that's trying to say is that anytime you have a number on the outside of any pair of parentheses, take that number, multiply it to the stuff on the inside. And keep in mind, anytime you're multiplying negatives with negatives, negatives with positives, stuff like that. The second thing that you can do is that you can combine like terms. Now, you can only combine like terms that are on the same side of the equation. In other words, if you have variables on two sides, you can't combine those. You can only combine what's on one side at a time. And then lastly, moving all of your variables to one side of the equation. Again, if it looks like you have variables on both sides of your equation, then make a decision about one of those variables, take that variable and move it to the other side using an inverse operation. In other words, we're trying to create zeros there, but we'll talk about that a little bit more. Let's go ahead and get started with the first method of multiplying using the distributive property. So, what's the idea here? Well, like I was saying before, the idea here is that you want to try to take any number that's on the outside of your parentheses, multiply it to the inside, and then solve the resulting equation. So for example, look at this one right here. We have a 2 on the outside of our parentheses. So what we're going to do is that we're going to take that 2 and we're going to multiply it to everything that's on the inside of that parentheses. So what happens? Well, 2 times x is just 2x. 2 times negative 1 is just negative 2, or just minus 2 in this case, and that equals negative 8. Now what you don't want to do is that you don't want to take that 2 and multiply with that negative 8. The reason why we don't want to do that is because that negative 8 is not in the parentheses, so please be really careful about that. Now, what do we do from here? Well, like I was saying, the whole point is that we want to get to a two-step equation, which are, like I said before, are the most basic type of linear equations. Now, why are they so basic? Well, here's the idea. Basically, the idea of a two-step equation is that you want to use inverse operations to solve your equation. And there is an order of a priority that you want to do when you're doing these. For example, you always want to focus on the side that has x on it. So in this case, this is the side that has x in my equation. So I'm going to be focusing more on this side than on the other side. And then what you want to do is think about, well, is there any sort of addition or subtraction in my problem? Absolutely. There's a subtraction of 2 right here. So what we're going to do is that we're going to use the inverse operation of minus 2, which in this case would be plus 2. Now here's the thing that we have to remember. Whenever you're solving an equation, you have to remember that equality is very important in algebra. What you do on one side, you have to do to the other side. So if I add 2 on this side, I'm going to go ahead and add 2 on this side. So what happens? Well, on this side, we actually create a 0. So we create a 0 pair. It's no longer part of our equation. So what's left? All that's left is just that 2x equals negative 8 plus 2, which should just get me negative 6. And all you do from here is, again, you apply the inverse operation. In this case, this 2 and this x are together, so that means that they're being multiplied. So what's the opposite of multiplication? Well, in this case, it's going to be division. So we're going to divide both sides by 2. So that means my answer will be x equals negative 3. So that's the whole idea with these types of problems, is that you want to distribute if you can, and then solve the resulting equation. So let's go ahead and do it one more time. We're going to take this negative 3, we're going to multiply it. So negative 3 times 2 is negative 6x. Negative 3 times negative 3 is positive 9, equals 12. From here, we do the inverse operation. We subtract 9 on both sides. We create a 0 pair here, so now all that's left is negative 6x equals 12 minus 9 is 3. You divide both sides by negative 6, inverse operation, and you get an answer of x equals negative 0.5, or another acceptable answer would be negative 1/2. So that's the idea. You see parentheses, you take that number that's on the outside, you multiply it. In this case, be very careful about how we are multiplying our integers. Negative times a positive makes a negative, and when you multiply two negatives, you make a positive. So that's the first simplification technique. Well, what would it look like if we needed to combine like terms to simplify? Well, let's look at this next set of problems. Basically, the idea of like terms is this. Like terms are basically any terms that have the same variable and same exponent. So basically you can only put together if they have the same letter and the same exponent. So when you're looking at a problem like this, you want to ask yourself, well, is there any x's or any variables that I can combine? Well, in this case, I can combine 2x and then plus x. It's super important that when you're going to combine like terms, that you include the sign too. So it gives you a better idea about whether you're going to be adding a positive or adding a negative. Now, why can't I just add 2 in this 6? Well, that 6 does not have an x. That's why we can't add it. They're not like terms. So if I add 2x and x, I get 3x. But that's not the only thing I can combine. I can also combine plus 6 and minus 4. So when I combine these two, 6 minus 4 gets me a plus 2. And I drop down at 14. And now notice that I'm in a situation where it's a two-step equation. So inverse operation, so minus 2 minus 2. We create a 0 pair here, so 3x equals 14 minus 2 is 12. And then we do the inverse operation of division here. We divide both sides by 3. X equals 4, because 12 divided by 3 is 4. So big idea here. You can only combine like terms to continue simplifying. You can only combine if they have the same variable and the same exponent. Now, again in this problem, we can combine negative 4x and positive 6x. Again, don't forget the signs. Circle those signs up. Group them up. So in this case, we have negative 4x plus 6x. That's going to get me positive 2x. But again, that's not the only thing we can combine. We can combine regular numbers, negative 2 and negative 4. So negative 2 minus 4 basically makes a bigger negative, so negative 6. And we bring down that minus 8, that negative 8. Again, inverse operations. Plus 6 on both sides. We're left with here a 0 pair, that creates a 0, so 2x equals negative 8 plus 6. That gets me a negative 2. Inverse operation. We can divide both sides by 2 after that, and all that we have left is x equals negative 1. So this is what it would look like if you were going to simplify using like terms. You will combine if they have the same variable and same exponent. Another thing, you can only combine if they're on the same side of the equation. Meaning that let's say I had a 2x on this side. Can I just add that 2x with everything that's over here? Absolutely not. Because you're assuming that that 2x is still positive when you combine. Which is going to segue into this next method of what should you do in case you do want to try to combine something that's on a different side. And that's what we're going to talk about, moving all of your variables to one side. So what does it look like? Basically, your problems will look like you have an x on one side and an x on the other. But this is already looking like a two-step equation. Why can't I just go ahead and just subtract 15 and then divide 10? Well, that's a good observation, but we usually do the two-step process depending on where x is. In this case, we have an x on both sides, so it's kind of difficult to say, well, which side is the correct side to work on. To eliminate that issue, all we're going to say is this. Let's decide on moving one of these x's to the other side. Now, from personal experience, from what I've seen, I think most people like to work on the left side of the equation line. So what we're going to do is that we're going to go ahead and move this 4x. Now, I can't just move the 4x just by writing it down here, 4x. I have to think about how exactly we're going to accomplish that goal. And here's how we're going to do it. You want to think about inverse operations again. If you're going to move anything on the other side of that equation line, you have to create a zero pair. You have to create the opposites so it can cancel. In this case, because I have a positive 4x, I want to think about, well, if I want to move this x to that side, what would be the opposite? Well, the opposite of this would be minus 4x. But if I do minus 4x on that side, I have to do minus 4x on this side. Oh, well, why can't I just add it? Well, okay, let's go ahead and add it. If you add 4x on both sides, you'll get 14x plus 15 equals 8x minus 3. You still have that x on the other side, so you didn't really accomplish what you wanted to. That's the reason why we want to think about inverse operations, just to make our life a little bit easier and to make the work a lot simpler. So we don't want to add 4x. That's not going to accomplish what we want here. So what we're going to do instead is we're going to do the inverse operation. So this creates a zero pair because they're opposites. What's left? Negative 3. On this side, we have 10x minus 4x. That's going to get you 6x. You bring down this bad boy of 15 straight down right next to that 6x. Now, it's a two-step equation. Inverse operation, minus 15 on both sides. This creates another zero pair. 6x equals negative 3 minus 15 gets me negative 18. And if I divide both sides by 6, I get x equals negative 3. So big idea here. If you have a variable on both sides, go ahead and decide on which one you want to move. And when you want to move it, create your zero pair. Think about the inverse operation you have to perform in order to move that variable. Let's go ahead and think about this one more time. In this case, we have negative 3x on one side and negative 5x on the other. Just for simplicity's sake, I'm going to go ahead and decide to move this negative 5x to the other side, just because I think most people are used to that. So, if this is a negative 5x, my inverse operation would be positive 5x. So I'm going to be adding 5x to both sides. So when we do that, that creates a zero pair. All we're left with here is negative 1. Negative 3x plus 5x is 2x. We're going to bring this guy down, this negative 8, and then we are down to a two-step equation. So we add 8 on both sides. We're left with 2x equals, this creates a zero pair, 2x equals negative 1 plus 8 is negative 7. We divide, oops, that's not right. Negative 1 plus 8 is positive 7. Oops. Divide both sides by 2. 7 divided by 2 is just 3.5. So x equals 3.5. Or if you're a fraction person, you can say that it's 7 over 2. So, what was the whole point of this video? This whole video was just about showing you 3 different ways that you could simplify a linear equation so you can get it down to a two-step problem. It's important that if you see parentheses that you multiply, if you see like terms that you combine them, but make sure that you are combining same variable, same exponent. And finally, if you have variables on both sides, decide on which one you want to move by performing the correct inverse operation. I hope you guys learned something new today. If you have any questions, please leave them in the comments below. But like always, please take care, and I'll see you guys next time. Peace.